first speech.
Absolute one that I don't want to.
I need the ukulele. I'm gonna practice.
And
We are live.
we're live. All right, welcome.
That wasn't funny.
So last time in Mr. Max class, we learned a little something.
Actually,
has a problem.
You could have watched it live.
I tried watching it yesterday.
Go
but didn't
home
come
and
out.
watch it or watch it later. I don't care.
Hold on.
I find
Tuesday,
it funny. The
I
day I get my
slept
car
all
back,
day.
I get jacked in
Oh my God.
What was that?
Everyone's talking about
Stop,
here.
but don't move your lips.
So you guys just keep doing your thing until you tire yourselves out.
So he tires himself out. It's gonna take a million
Mr.
years.
Mac,
Hi.
you're not feeling well. I feel like this is unnecessary.
This isn't unnecessary.
Here, let's Brock do it. Freaking coffee, so.
Here it is.
You should just like
Yesterday.
act like a chicken.
Got an update for like those training videos.
All right, C of numbskulls. I need you to pay attention now. So, here it is. Yesterday, we talked about isosceles triangles. There's a theorem that has to do with isosceles triangles. So it says if two sides of the triangle are congruent, in other words, if you have an isosceles triangle, then the angles opposite those sides will be congruent. So if we have this, that implies this. Pretty cool with that. Okay, the converse of that is the reverse. Now, not all theorems are true both forwards and backwards, but this one does go both ways. So, if we know the angles, we can also say that we get the sides for free. Okay? So you're going to need those today to solve these proofs that we're looking at that are in this packet. Big hint, the packet's called the Isosceles Triangle Proof Worksheet, right? So, I bet we're going to be using these.
Wow.
Remember, the regular theorem for isosceles triangles is when you're given the sides and you get the angles. The converse is when you start with the angles and you get the sides, okay? So here we go. Look at this one. First off, whatever they give us, we should probably mark down on the diagram. So I'll do that. Looks like D and E. So angle D is this angle. And it's congruent to this angle, angle E. However you want to mark that, it's fine. Then it says A is the midpoint of DB. Now, we've discussed this very briefly, but I think you guys can infer, if A is the midpoint of DB, what does that tell us about these two segments?
They're equal.
They must be, right? Because A cuts it in half. So these are going to be congruent.
That's bonkers.
That goes back to the first thing we learned, doesn't it?
Yeah, it really does. B is the midpoint of AE, so here's AE, and B's the midpoint of that. So that means these two are equal. Well, if that's already a 1 mark, right, that must be 1 mark as well.
You could just do it that the line is broke up into 1, 2, 3 triangles, which their bases.
Yep. So,
Hey,
what are we trying to do? We're trying to prove CDA congruent to CEB. I'm going to color those triangles in. You should not do this. I just want you to be able to see what our goal is. So CDA is this triangle, and CEB is this triangle.
angle, side angle.
So we're going to try and prove them congruent. Right now, we don't have enough information to get it done because all we have is an angle and a side. If we had more information, we'd get it done.
They're shared. A and B are the same.
I've got lots. So
Wow.
Here's
Can
red.
you not use side angle side?
You just sound like the rabbit. Sound like the rabbit.
All right, so
Rabbit.
we're not here out of 0 right now. All right, so I wish it was this one. So
Yeah.
we need to prove these two triangles congruent. We cannot do that with the information we have right now. We need to get more information. So the way these problems are going to work is you're going to try and get as much information about these triangles as possible. Then you're going to prove the triangles congruent, and then you're going to prove their parts congruent, essentially. So this one, we just want to get the triangles the same. Okay? So right now, not enough information here or here. We could drop a perpendicular, right? We learned that yesterday. The let there be line postulate says we can drop a perpendicular whenever we want. But here's the thing. Yesterday, when we started out, we had a single triangle, right?
Yeah.
It's hard to do a lot with just one triangle, right? So when we dropped that perpendicular, we created 2 triangles, and we got an angle for free because we knew it was 90, right? That was really beneficial. Here, we've got a couple triangles to work with already, right? We got 4, actually more than 4, we got 5. Let's not create more triangles for us to work with. Let's just go with what we have. 5 triangles, a big one, 1, 2, 3, and then big one here, big one there.
What do you mean big one there?
Giant one,
Yeah.
3 small ones, and then 2 medium ones. Yeah, I know, right? Seeing it's half the battle. So, let's not create more triangles. We've got enough to work with. If things get really bad, maybe we can try dropping that perpendicular. but in general, no need to do so right now. It made more sense yesterday because we only have one triangle. There's really not much you can do with one, right? So, here's what we're going to do. We know, again, hint, 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 that this theorem is going to be used. Isosceles triangle theorem says if we know two sides, then we get the two angles. So this implies this.
Don't we know?
We also know the opposite, the converse. If we have the angles, we get the sides. So, I'm going to give you a little bit. What do you see?
Sides.
Wait a minute.
Two sides. I see two
Raise your hand, yes.
Wait a minute. Never mind.
All right.
It would be wrong.
Anybody else?
No.
Flofford, what do you see?
Two sides are the same.
Which two sides?
CA and DA.
CA and
Like
DA?
not, they're not like no, like I'm saying like CDA.
CA and DA?
No, like
CA.
DA is equal to
B.
AB and CA combine those two triangles together. You know what I'm saying or no?
Not at all.
You don't know what I'm saying?
Nope. Anybody else?
I was saying that I see C and D and then C and E, I think.
CE. CE.
How do we know these two sides are going to be congruent?
I don't know, that was just a thought.
CA, CE.
Oh.
Here's what we have to work with. If we know the sides are the same, then we get their opposite angles, right? We also know if we have the angles, we can get the sides.
So that means since angle D and angle E are the same, that those have to be
Yep, we were given that.
Yeah. And that means the sides have to be the same?
Which sides?
CD, or we could say CDA and CE.
No, we're talking about sides, not angles, so don't need three.
Well, since you could say CD,
CD.
CE are the same because they share the same angle.
Exactly. So, check it out. This angle opens up into this side, and this angle opens to that side. The big triangle, CDE, is isosceles, right? It has two angles here. A lot of you guys are focusing on the close-up, and you're saying, look, an angle in this triangle. Look, an angle in that triangle. When in reality, those two angles participate in this triangle, right?
Yeah.
So don't forget to look at the big picture. This side must be the same as that. So this triangle is isosceles. So what we're going to say is now which theorem did we use? Did we use the isosceles triangle theorem or did we use the converse? The theorem, the straight up theorem just says we have the sides, we got the angles. The converse says we have the angles, we got the sides. Well, we had the angles, we got the sides. So by isosceles triangle converse. So I could write it like this. I would encourage you not to, so just wait. That's isosceles triangle
I want to be Billy.
theorem. And we wanted the converse, right?
Converse.
Now that is a mouthful.
Yeah.
So instead of writing that, you can do this by just saying that. That's an isosceles triangle. And then theorem is TH,
C.
and then writing converse. Much shorter, right?
Yes,
TH.
sir.
THM stands for theorem. A lot of people have been confused by that today. I'm not sure why, but fair enough. A lot of people have. All right, so by the isosceles triangle theorem converse, right? That means the angles are the same, so the sides must be the same. We know that the sides are the same. So CD is congruent to CE. Are you with me so far? We got two angles here, and so that's going to be an isosceles triangle. So this and this are both the same.
So I had semi the right
Yeah.
idea. Just didn't say it
Cool.
Oh.
So, now do we have enough information to prove those two maroon triangles the same? We do. Side, angle, side. Right?
Yeah.
So let's do that.
Patriots logo.
By, side, angle, side. I want to write that in print. By side, angle, side, we know that the two triangles are the same. I'm going to call this triangle on the left triangle ACD. I try to keep it in alphabetical order for the first one as much as possible. You don't have to. You can call it DCA or CAD. Just make sure your letters line up when we're done, though. So ACD congruent to the other triangle. Well, if I look at angle A on the first triangle, that's this angle right here. Well, it is made up of the unknown side and the pink side. So if I go over to the other triangle and find the unknown side and the pink side, I'll have the matching angle. So unknown side, pink side. So B is going to go with A. So B. C on the first triangle is made up of the I shouldn't say the hypotenuse. The black side and the unknown side. Black side, unknown side, it's going to go with itself, right?
Yeah.
C for both. And then D is going to be the black side and the pink side. So black side, pink side. That's going to go with D.
Alright. That part I got right.
Cool. All right. So now that we know the triangles are congruent, we've done it. That's what they wanted us to do. Now they said CDA and CEB. I chose to write mine as ACD. So if I want to get full credit, I need to make it look just like this. So I'm going to rewrite this as CDA. Now when I do that, I can tell which ones go where pretty easily. C was the middle letter, so C is going to be the first letter here. Does everybody see how C and C go together?
Yeah.
And then D, that means it went with E, and A went with B.
Oh, it's just bad.
So we're done.
Can you like go through that slowly?
Yep.
I mean, I got.
So I want it to look just like this, so I can call it a day, right? And so instead of writing ACD, I'm going to write CDA.
Or just write that.
Now notice that C here, right, goes with C here. So C and C go together. See how D and E go together? So when I write D, I need to write E. A and B go together, so when I write A, I need to write B.
No, I get that. I got lost after you put theorem converse. Then once you put the CD and the C, that's where I got confused.
Okay, cool. So all this allows us to say these two are the same. That's what you said, right?
Yeah.
That's what I wrote. And then after that, I said by side angle side. See how we have side angle side for both triangles?
Yeah.
Then we can say the triangles are congruent. This one and that one.
Oh.
Better? How do you feel about that? As bad as you thought it would be? I think the hardest part is seeing it, right?
Attention.
The hardest part is seeing it. And the more practice you have with seeing it, the better you'll get.
Yeah.
Why
Okay?
did you color that in?
I don't know, because I wanted to.
That
It looks
hurts
cool.
my
You know
eyes.
Back, you feel sick.
Oh, yeah.
No.
I've been taking a lot of Dayquil. Little bags of germs have infected me. More times this year than I have in the last 3 probably combined.
If you eat spicy
I
food,
didn't
do
do
your
it.
7 spice soup or whatever,
I do
you
eat a lot of
won't
spicy
get you
food.
won't get sick.
That's not how that works.
That is true.
I didn't go to the bathroom.
If you
Right.
eat a lot
I
of
could
spicy
drink.
food, he'll just
When he gets back,
Yes. All right, so we're given the triangle ABC,
There's a mouse.
and they told us that CA is congruent
There's
to
a mouse.
CB.
What? There's a mouse.
Oh, okay. I was like, what?
Sometimes when I copy and paste from my old diagrams, my mouse gets caught in it. Sorry. CA and CB are the same. In order to represent that, I can't put a tick mark because if I mark it here, it's looking like I'm talking about CR. If I mark it here, it looks like RA. So I'm going to do this. I know. Hey. Softer, put it away and turn around.
all right.
No one wants to see it.
Well,
He's
yeah,
working.
if it's what I think it is.
No.
I
AR and BS.
No.
did not.
AR is this, BS is that. So mark that on your diagram. One of the silliest mistakes you can make is to not mark everything at the beginning. We also know we have some perpendicular lines.
Yeah.
So DR and AC are perpendicular. Here's DR. Here's AC. So where they intersect is going to hit at 90 degrees. So that's going to be here and here.
Wow, this is kind of tricky. Just a lot of stuff. So,
DS and BC are perpendicular. So same thing on the other side. So everybody see how I got that?
yeah, I understand it. It's just like a lot to take in.
Yep. So now we've done everything. We've labeled it on our diagram. Now you should not do this. I'm doing this so you can see what our goal is. When I say DR and DS is what we're trying to prove congruent, it feels very nebulous. But if I tell you that DR is this and DS is that, it's much easier to see what we're trying to prove congruent, right? That's our goal. I'm not saying they are congruent. I'm saying we need to prove that these are. That's why I kind of like colored them in, right? Don't do that. It'll screw you up. All we need to do is make sure these two are congruent and then we've won, right? That's our goal. So here's what I'm going to say. I've already got lots of triangles to deal with, right? I've got 1, 2, 3 to deal with. I probably don't need to make any more by dropping a perpendicular. Could you? Sure. You could drop a perpendicular there. Then we got 2 right triangles, right? We could do lots of good stuff, right? I'm saying we've got enough triangles. Let's try it without making things more complex. So if I can prove these 2 triangles congruent, this triangle and this triangle, then that means their parts are congruent, so these guys will be congruent, right? So my goal is to get those 2 triangles congruent. Right now I've got an angle and a side, and that's it. Now, it is a right angle, so HL is on the table. So if I can figure out the hypotenuse matches, right, then I'm good,
HL is all
right? Then HL is all good. But I can also figure out other stuff like the angles here, right? So, again, we have the isosceles triangle theorem, which says if you know the sides, you get the angles, right? And we have the converse, which says if you know the angles, you get the sides. What do you see?
I see.
See,
trees of
it's
green.
not Converse, it's the other one.
It's the regular theorem. We already have the sides, so we're going to get the angles. Does everybody see that?
Oh,
Yeah, I see the
But-
Again, don't forget to look at the big picture.
let's
What
go.
else are we gonna think about?
You see it now, Jenna?
No.
So this side and this side are congruent, right? They gave us that. So that means their opposite angles are going to be congruent. Do you see the big triangle?
Ooh, there's something
Angle
there.
there, angle there.
I don't know what's
Yeah. I
If the
see
sides
it.
are the same, then the angles across from them are the same.
Anybody?
Let me go back here. Gentlemen, zip it. If the sides are the same, I need her to be able to hear and focus.
I'm sorry.
Okay? So these sides are the same, which means their opposite angles are the same.
Okay.
Okay? That's the isosceles triangle theorem. So sides are the same, opposite angles are the same. Cool?
Okay.
So I'm going to say by isosceles triangle theorem, that's the shorthand for it, right? Isosceles triangle theorem, THM. I know that angle A is congruent to angle B. So I've got some more information about those maroon triangles now. The question is,
Isn't that the same? That looks like the same as the other theorem.
the other one's just the reverse of it, that's it, right? This time, they gave us the sides, look, Schlaffer, look at me. They gave us the sides, and we got the angles.
No, I get that, but the way you marked it looks the same.
Yeah,
Is it?
no.
What's different? The triangle. By triangle, you say triangle, the dashes are in the same spot.
Yeah, the other one said converse.
Is that supposed
Oh.
to stand for zero?
Yep, THM. All right, so now that we have these angles, look at our maroon triangles. Can we prove them congruent? Do we have enough information?
Yeah.
We do. We have side, angle, side. I'm sorry, I said that in reverse. Angle, side, angle, right? Are you with me?
Yeah.
Angle, side, angle for both. So we can say by angle, side, angle, those two triangles are congruent. Let's name those triangles. Looks like we have triangle.
RAD.
Well, I'm going to try and keep it in alphabetical order, but you can call it that if you want.
Oh,
ADR.
all right. I just
Again,
saw
if you
rad.
said RAD, that's fine. Just make sure your letters match up,
I just saw red.
right? So whatever you have for R, if you wrote R first, we go
flip it
here.
off. Yeah, flip it off.
Good. So angle A in the first triangle is made up of the orange side and the unknown, right? The hypotenuse. Orange side and the hypotenuse. We have orange and the hypotenuse here. And that makes up angle B. So A and B are going to go together.
D for
Angle D is made up of the unknown side and the hypotenuse. Unknown side, hypotenuse. So D goes with itself. And then R is orange and unknown, orange and unknown. So it goes with S. Everybody cool with that?
Yeah.
Matching up those letters is super important because, remember, we didn't want to prove the triangles congruent. We wanted to get the parts congruent. So now that we know these are congruent, we know their parts should match up, right? So the way we say that is we say by CCP.
What's
Great question. CCP stands for corresponding congruent parts. So the parts of the if the triangles are congruent, then the parts should be congruent. Which parts? The corresponding ones. The ones that are in the same relative spot. So check it out. We wanted to prove DR and DS, right?
Yeah.
You see how DR and DS are in the same relative location? See how they're corresponding? Then that means we can say they're congruent. So by CCP, DR congruent to DS. And now we're done.
It's not hard. It's just seeing it. As soon as you start seeing it, it's gonna.
Right. So again, our idea is to get as much information about these triangles as possible. Then we're going to try and prove them congruent. And then we're going to say, because they're congruent, their parts are. The thing that allows us to say that their parts are congruent is CCP. Okay? If you missed yesterday, if you've ever been to Sunday school, and they ask you a question, you haven't been paying attention? 9 times out of 10,
It's
the answer, Jesus. We'll get you a piece of candy, right? And here, CCP is that answer.
So I would say CCP.
That's horrible.
Is the answer Jesus?
You're permanent.
Shout out to Theta McMinn, my old Sunday school teacher. She's probably dead.
Rest in
Ancient
peace.
when I was like 5.
Like,
That is very depressing.
you don't know she's dead though.
I don't know so.
Should
In
we
fact,
preserve
in
that
fact,
line?
funny story. I did the same bit, right, when I taught last year in Indian Creek, and the aide that was in the room with me was like, "I know Theta McMinn," right? They were like friends. They went like to church together or something, and she's like, "No, she's alive."
I bet your aide looked like Miss Braddis.
No.
Yeah.
Deborah.
She had a "Can I speak to a manager" haircut. That's all I'm gonna say.
Karen!
All right.
Karen.
Karen.
Deborah.
Maybe she had a resting bit.
Veronica, please.
All right. So, like a dead cat, we're gonna back up and go over it again.
I thought
you were gonna say
that ever again.
Mr.
I miss
Miller.
Oh, I'm sorry.
Nicholas Paisley is wrongfully in jail.
Why are we talking about
He's not. He's a brother, dude.
He's
All right,
insane.
gentlemen.
What? Wait. Huh?
Don't listen to what
Someone
Schlopper
say
says.
the cat joke again.
Lorelei and Schloffer switch spots.
No.
No. No, why?
Because I
Pretty
can't
day.
be next to Jacob. Well, he just mentioned somebody with their brother. So.
Yes,
I swear to God, Schloffer, sit there.
You're
Dan?
not sitting at that desk.
You're fine. He can't see you. It'll be fine.
Nick Paisley.
That poor
Pretzel's
child.
right there.
Chill with that noise.
Harassed
Did you
by this
say
man.
cat joke?
No.
No,
Yes, he
Oh
did.
my God.
I didn't say it.
Freckles on his face.
What?
It's like a dead cat when you get back and go over.
Run out, Schloffer. All right.
That was grandson.
So, here's what we did. We said that since these two sides are the same, then their angles will be the
Brought
same.
it up.
Shut up. If these two sides are the same, these two angles will be the same. That's this theorem. So A and B are the same angle. Then by angle side angle, we said the triangles are the same. And if the triangles are the same, their parts are the same. Which parts? The ones that correspond, and that's what we wanted. How do you feel?
Feel good.
Jenna, do I have you up to here?
No, when she does that
What about here?
handshake, she's-
Stop.
Yeah.
Yeah, for real?
Yeah.
How about here?
Yeah.
Yeah.
You don't know those could have been.
That's true, but you know what? We're operating on honesty and communication here, right? If you want to learn, we have to be honest with each other. And sometimes that means saying, I don't know.
Never honest.
Good luck learning that way. It took me until senior year of college to figure that out. It doesn't work, guys.
And it's
It's
too
really
late.
okay to have to know stuff. This is the first time you're being shown it. That's
For
normal.
the last 16 years.
I know, but like, you probably didn't ask for help, or if you did, you had a teacher that was really mean to you, and then you stopped asking for help, right? So,
I had dents the
how
face.
about you take advantage of having me as a teacher, and you be honest, right?
Squeaky. Stall for us. Why?
So, next, BCF and DCE. We know these are congruent. So here's BCF,
Yes.
and there's DCE.
They're the same thing because they intersect
Nope,
each other.
if you add them both up, it'll be more than 180 because there's overlap, right? But there's something like that. I like how you're thinking.
They're both obtuse.
C is the midpoint of BD.
So,
You just said that.
So what does that mean?
It's
in between it.
Yep, so BC and CD are the same, right? C's the midpoint, cuts it in half. And then CE and CF are the same. So here's CE,
Is that even
and here's
relevant?
CF. Huh?
Is that relevant?
Yes.
Is that
Is it?
3 for all of them or 2?
All right, so we want to prove that ABD, that's the big triangle, right? The whole big thing. We want to prove that isosceles. So remember, the definition of an isosceles triangle is this.
Yeah.
Two sides the same, right? So if we can prove two sides are the same,
Then we've got it.
then we win, right? By definition, that's an isosceles triangle. So here we go. Here's my logic. If I can prove these two angles are congruent, then that means the two sides are, right? And I win. So how do I get those two angles to be congruent? Well, prove the triangle's congruent, right?
Oh, so.
If I get these two triangles to be the same, then their angles will be,
Side angle side.
right? So we want to do side angle side, but here's the problem. That angle is not referring to this angle. It's referring to the big angle. So we need some way to get this guy, and then we can do side angle side, and then we'll know these angles, and then we'll know these sides, and we'll win. Okay?
Hey,
Yes.
wait, did you already say that that those two angles are equal?
The red angles are the same, yeah.
Wait a minute.
No, not. I'm talking about. I don't know. How to say
I have
it.
not said any other angles are equal yet.
But like the angle. I don't know.
BCE.
Yeah, you said that's equal to FC.
We're gonna try and prove that, yes.
Oh.
Because if we get that, then we can say side angle side. So Don't write, just watch, because you literally do not have to write any of the thing I'm doing here, okay? We learned this last semester, so it's going to be a shortcut. We're not going to write the whole thing out, okay? So, here's what we're doing. We're going to say, let's get some color in here. Let's do this green. Let's do this as light blue. And let's do this one as pink. Cool. So, here's my logic. You ready for this?
No.
The red angle, remember colors mean they're congruent, right? So if they're both red, they're both congruent. Is made up of two parts. This red angle right here is made up of what two parts?
Blue, green.
Blue and green. A blue and a green angle. I could write this out with letters, right? I could. But I'm going to use colors because it's a lot faster. Now I know that by angle addition postulate, right? Angle addition postulate says the two little pieces add up to the big one, right? That's fine to say. Okay? And it's a postulate because of course it is, right? No theorem there. Just we have to accept that to be true. The other red angle, which would have a different name, but it's still congruent to the first red angle, is made up of two other pieces. What two other pieces, Schlaffer?
I don't know. I was just gonna answer that. I wanted to ask something.
Pink, and does the pink look like the red? Sorry, guys. Pink
Green.
and green.
Yeah, those look.
Sorry, guys.
That's
Now, if they both add up to the red, don't they equal each other? Right, by substitution?
Wasn't the
Again, I'm not writing that all out. Okay?
we don't need is the pink 60?
We don't know that, Schlaffer. It could be. It might not be.
I think it is. It'd have to be. Because they're equal.
All right, so check it out. If they both equal the red, then they equal each other. This equals that. With me? And then by subtraction property, what do I know?
pink and orange.
Blue and pink are the same, right?
Well,
Yeah.
That's it.
You just.
Wait, how do you know that?
So check it out. I know that this red angle is made up of blue and green, right? So I wrote that.
So you use substitution.
I know this red angle is made up of green and pink, right? So I wrote that. If they both equal a red angle, red means they're the same, right? Then they must equal each other. So blue and green should equal pink and green. I wrote that. If I subtract the green angle from both sides, look what I get. Blue equals pink. So what did we do to set this all up? We did angle addition postulate and then substitution. We're just going to say, by angle addition postulate, I know that blue is the same thing as pink. Now we need to give names for these. The blue angle is BCE. Thank you. And the pink angle is, if I did BCE, I want to do DCF. Right? That's what we found out over here. Now, Jenna, you don't have to write any of this. I was just showing you how I knew that.
Yeah.
This is the shortcut for that. If you have overlapping angles, you're probably going to use angle addition postulate to find them, right? Okay? Same thing with overlapping segments, segment addition postulate, right? So we know this to be true. So that blue angle and the pink angle are the same. Now check it out. Do we have side angle side for both? Oh yeah, we do, right? So now we can say the triangles are congruent. So I'm going to say that this triangle is congruent to this triangle. How do I know that? By side angle side. Let me zoom out.
You were right. Yeah.
By side angle side. The first triangle I'm going to write as BCE. Congruent to the second triangle. Now B is made up of the blue side and the unknown. D is made up of the blue side and the unknown, so they go together. C is made up of orange and blue. Orange and blue is also C on this triangle. E is orange and nothing. Orange and nothing is F. How do you feel about that?
I love it.
Now, we don't care about those triangles being congruent. We want to prove ABD isosceles. So what we want to prove is that these two angles, this here and this here, are congruent, right? And we can do that now. If the triangles are congruent, their parts should be, right? If we get these angles to be congruent, then we get the sides to be congruent, and we win.
So does that mean if EBC and FCD are the same, then B and D, or angle EBC, all those angles have to be the same, right?
By CCP, corresponding parts will be congruent. So B
Whiskey.
is congruent with what over here?
D.
B is going to be congruent with what? D. See how they're corresponding?
Yeah.
Right? So angle B congruent to angle D. We can say that. Let's mark that on our diagram.
Do we need to do that?
I think it'll help, because now that you see that we have two angles here and here, doesn't that mean the sides are the same?
Yeah.
Right?
Well, isn't. Wait, why did you just mark that on a triangle?
I put it here and here. Sorry that this is the same color here. Let me make these both black. Because they're the same. So, Jenna,
Yeah.
since we have both blue angles, right, we just did that down here, right?
That's my notification. I'll turn the sound off. I'm sorry. The minute I'm sorry.
Sloffer, let me have a heart to heart, okay?
No.
You used to be a kid that could make me laugh like pretty
No,
much
I
every
didn't
day.
mean
Shut
to.
up and listen, my God, this
I'm
is your
sorry.
problem, okay?
Yeah.
So, you used to be a kid that could make me laugh every day. And
Yeah.
when it's funny, that's great. But like now, it's just like,
not fun.
your sauce is weak, man. Like
Yeah.
either get better or just like stop. Like come up with better material,
That was legitimately an
okay?
accident.
I know it was, but like, it just takes up more time when you talk about it.
Yeah.
Alright, so B and D are the same angle, Jenna, right? We proved that by they correspond, right? And if they're the same angle, then that means that this triangle must be isosceles. See how this angle opens up to this side, and that angle opens up to this side? So now what we're going to say is that these two sides are congruent, okay? Are you with me up to there? Okay, so I'm going to write that now. So by, now what's the theorem that says if the two angles are the same, the two sides are the same? It's this guy, right? Is it the converse or the regular?
Angle.
We're given the angles and we got the sides.
The Converse.
The converse, right? We have the angles and we got the sides. I'll be with you in just a second. By isosceles triangle theorem converse, we know that AB congruent to AD. Goes Vic. How can I help? For real?
Well, yeah, because I forgot. It says proof triangle not CD is congruent to CS.
Yeah. We're trying to prove that ABD is isosceles. So we're not done yet, but we're almost done. There's one more thing, right? Does everybody follow me up to here?
Yeah.
Okay? How about here? Do you follow me up to there?
Yeah.
These two are the same by side angle side.
CCP.
CCP means B and D are the same. And then I can say that if those two angles are the same, then those two sides are the same by that theorem, right? Isosceles triangle theorem converse. Now that we know these two sides are the same, that fits the definition. Oh, I'm sorry, you can't see any of this stuff. Please tell me. If both these sides are the same, then that fits the definition of isosceles, doesn't it, right? So we're going to say by definition, triangle ABD is isosceles, which is exactly what they wanted us to prove. All right, again, we're going to back up and go over it again, okay? All right, give you a second to think, and then we're going to go over it again, okay? So here's what I did. I said, I know this angle and this angle are the same by angle addition postulate, right? We have some overlap here. If we cut out the overlap, what's left over is the same, okay? That's angle addition postulate, so I wrote that. Then, thank you. Then I said side angle side for this triangle, right? Side angle side.
Yeah.
So now both triangles are the same. Then I said if the triangles are the same, then their parts are the same, and I wanted these parts to be the same, so then I could then say that must be an isosceles triangle, because these two are the same. How do you feel about that logic? Follow me? How's it get? Dana. Wonderful. Kozovic. Do I have you up to here?
Yeah, I need to like know how to do that. You know
Are you thinking ahead, like, could I do that on my own?
Yeah.
Okay, great that you're thinking ahead, but here's the thing. Probably not, and that's okay. You have to practice it more on your own to get used to it. You should feel a little bit like we're floating in space. There are no steps other than this. The general concept is get as much information about your triangles as possible, right? Get some angles matching, something like that, right? Until you can prove them congruent. And then once the triangles are congruent, use their parts to prove what you want, right? So get the triangles congruent by getting as much information as possible, and then use that congruency to say, well, if they're congruent, their parts must be congruent, right? And that's going to help you get the last bit. Okay. This one was a tough one. Are we okay with the idea? Do I need about 50? All I need is about 50.
Yeah.
That's it. That's great right now. Okay? No quiz this Friday. All I need is you 50 right now, okay? Let's try 4. All right, here we go. Marking the diagram. Here we go. So,
Let's go. There's no cursor in this one.
I know, sorry guys. No mouse. LM and OP.
Oh.
Yeah, I did that. Are congruent. So LM, OP. You were the only class I got that. Thank you.
I don't get it.
LM and OP.
I'm gonna
LM and OP.
ABCs.
LM and OP.
That's funny.
We had to back up that one and go over again, right? All right, so
Just like what?
I don't know what you're talking about. NLO and NOL, those two angles. NLO is this angle right here. And NOL is here. What do you notice about that upside down triangle? It's going to be isosceles, isn't it, right?
Yeah.
So that's the thing. Don't mark it yet, right? Because we need to tell why. That wasn't given to us. Then we have these two perpendicular statements. ML and LO are perpendicular. That's this right here. It's going to look ugly, but that's okay. That's a right angle. And then so is this. That's all they're telling us, right? All that means is that that orange angle and whatever this is must add up to 90, right? That could be something we could use. All right, so lastly, what are we trying to do? MN, NP. We're trying to prove that this is the same as this. So I'm trying to prove this and this the same. So follow my logic. If I can prove that this triangle and this triangle are the same, that means their parts are the same, right? And I win. So how do I prove those two triangles the same? Well, I need a lot more information. Right now, all I know is one side, right? How can I get more? Well, didn't we mention earlier that this thing's an isosceles triangle? Has to be. I know that by isosceles triangle theorem. Is it the converse or the regular theorem? We're given the angles. Isosceles triangle theorem says if two sides are congruent. So we're using the converse, right? If they give you the angles, we're using the converse. So by isosceles triangle theorem converse, we know that this side and this side are the same. Names of those sides are LN and NO, or ON, I should say. Again, I try to match up the letters as best as possible. If N second, should be second for both. All right? Now, do we have enough information to prove the triangle is congruent? Nope. All we have is two sides, right? So, how can I get more information? I bet this angle and this angle are the same. And I bet I can prove it. If, not cap, if orange and green add up to 90, and if orange and green add up to 90, shouldn't those two angles be the same?
Yes.
That's angle addition postulate. Now before I did two different colors to not assume they're the same, but I think we can tell. Orange plus something is 90, orange plus something is 90. Well, it's gotta be the same something, right? So we're gonna say by angle addition postulate. I know that the green angle over here, which is MLN, is congruent to the other green angle, PON. Pond. Now, I've gathered enough information to prove they're congruent. Is everybody good with me up to here?
Yeah.
Angle addition postulate gets me those angles. That's kind of the tricky one, right?
Yeah.
This plus orange should get me 90, right? This plus orange should get me 90, so those have to be the same, right? Follow that logic, Jenna? You with me? Okay. Again, getting the sides, converse of the isosceles triangle theorem, right? Cool. So now we have enough information. Side, angle, side, yeah? Side, angle, side. So now we can say by side, angle, side, those two triangles are congruent. So I'm going to write that. By side, angle, side, the two triangles are congruent. The first triangle I'm going to write in alphabetical order as LMN. And the other, well, L is made up of orange and blue. O is made up of orange and blue. M is made up of blue and unknown. Blue and unknown is P. And then N must go with N. Now we're not done.
Oh.
If the triangles are congruent, their parts should be congruent, yeah?
Sure.
So by CCP, right, that's the thing that allows us to say that. By CCP, MN, see how MN is second and third here? PN. MN congruent to PN. And I know the top says NP, that's my mistake. Rewrite that as PN. That was my bad. I was being sloppy when I copied and pasted stuff over. It's really hard to put that into words, so when I can find something that's perfect for what I need, I just box it. But this was, I needed it to be PN, and it was just NP. But shouldn't have copied and pasted it. And now we're done. All right, time to back up and go over it again. First off, these two angles imply that this is isosceles. You with me, converts? Next, AAP says I can get those angles for free.
Yeah.
Right? Then I got side angle side, so those triangles are the same. And if those triangles are the same, their parts are the same, namely these parts. How do I know they go together? Because they're corresponding, same relative location.
If you flipped it upside down, it'd be the same. Not really.
That's not what we're doing. We're not flipping to get things in place.
I don't know
Drawings
why
can be
I said-
misleading, okay? It's because they're in the same spot. See how MN and PN are in the same spot?
Oh,
They
that's
correspond,
right. Okay,
so they go together.
that was my
So for
point.
instance, if we wanted to prove that this angle was the same as this angle, well, that's angle LMN. LMN should be the same as angle OPN. OPN.
Hold it.
See what I'm saying?
Yeah.
Right?
Yeah.
The letters matter, the order that they're in. That's why we spend a lot of time to make sure they're right.
Alright.
5 is for homework.
Alright. Yeah.
Let's do the filling out the chart or filling out the diagram together. ADEB. That means ADEB is a line. Okay, so that is in fact a line in the bottom there. Okay, you can assume that's a line. Do not miss out on this. This is homework. I need you to try this. AE and DB are the same. AE is this. DB is that. We have some overlap. I bet we're going to use segment addition postulate, right?
I bet you're right.
Next, CDE and CED are the same. So that means these angles are the same. What does that tell you about triangle CDE? It's isosceles, right? Using that theorem. We want to prove ACB is isosceles. ACB is the whole big thing. So again, if you get these two angles, we get isosceles, right? Try it on your own.
Oh.
Best of luck.
Can I pass?
Yep.
I'll show it today. I'm gonna bring in some ants and you can't
No,
stop me.
I can't stop you.
No, you can't.
Oh my God, do you see what I just wrote? By
By.
CCP. No, I'm writing a pass.
You should do that. Oh my god. Dubai MAC. Wait, did you just write Kayla on my paper? Whoa, Kayla Carpenter. What are we doing tomorrow? What if I bring the ants in, like, in my pocket or something?
No, don't
That's
do that.
disgusting.
It's even worse.
No, it's not. What's disgusting about an ant?
No
They're
way.
literally
They'll be running around at your pocket. They'll get out everywhere.
No, they won't.
Yes, they
And
will.
they can't do anything if they don't have their queen. Actually, I couldn't even bring in ants until spring anyway, because like I don't have any active colonies right now.
There
so.
you go.